In this lecture, we're going to look at an application of everything we've learned so far. Okay, and what we're going to look at is called least squares problems. Okay. Let's say that you have 3 points. Say these are the 3 points. Like that, okay? And you want a line y equals to c0 plus c1x that goes through all 3 points. We would want each point to lie on the line, giving us the following system of equations. C0 plus 2, C1 equals to 1, C0 plus 3, C1 equals 4. Okay, now the way I'm getting this equation here is I'm plugging in the x value 2 and the y value here 1, and so I get this equation. I do the same for this point, and so I get this equation, and for this point I get this equation. Okay, so now I have 3 equations. Okay, now this system of equations can be written as a matrix equation, ax equals to b, where our matrix A is equal to 1, 2, 1, 3, 1, 5. X is equal to C0, C1. And B is equal to the column consisting of these numbers. Okay, now let's look at the system of equations right here. Let's do equation 2 minus equation 1. So then we get C1 is equal to 4 minus 1, which is 3. Let's do equation 3 minus equation 2. Then we get 2c1 equals to 9 minus 4. So solving for c1, we get 5/2. But c1 we found was 3, so this is a contradiction. And so the equation ax equals to b has no solution. So the 3 points do not lie on a line. Now, what we can do is try to find a line that best fits the 3 points. Okay, since there is no x, okay, there is no x such that ax equals to b. Instead, we can find a vector x such that find x such that ax is close to b. Okay, since we can't have ax equals to b, we at least can try to find an x that makes ax close to b. Okay. In other words, we want a vector x such that the distance between ax and b, minimized. Okay, we want to minimize this distance here. This is called the least squares problem. Okay, it's called least squares because when you take the norm here, ax minus b, you get the square root of ax minus b dot product with itself. And that dot product is a sum of squares. The least squares problem doesn't just arise when we want a best fit line. It arises whenever we want an approximate solution to a matrix equation of the form ax equals to b. Now, a vector x that minimizes this distance is called a least squares solution. Least squares solution. Least squares solution of this matrix equation, ax equals to b. Now, it turns out that the set of least squares solutions of ax equals to b consists of all and only the solutions to the matrix equation given by this. A transpose A x equals A transpose B. Okay. Now, the matrix equation here gives a system of equations, and the equations are called the normal equations. Normal equations for ax equals to b. Thus, in order to find a least squares solution of this, ax equals to b, we can simply find the solutions to this equation, okay?